Hello, in this video I'm going to be demonstrating my third year project. That's my dissertation project for my third year, which was carried out between the first and second terms. The entirety of the first and second terms I was working on this, just had to devote a bit of time each day to contributing a bit to this project. And through the Easter holidays I did a big 18,000 word report on the final product, and this is the final product. And obviously it's not the most beautiful looking thing, but that definitely wasn't the priority. The most important part of this project was the artificial intelligence involved, and that being planning and search. So the idea is we have a robot in this here environment which uses search to devise routes between key locations, then uses planning to order its routes so that it can sensibly solve all of its goals. So I'll first have a look at this options panel, which gives us all the things that the user has to play with. So I've created this interface myself. Obviously it doesn't look very professional really, so I think you'll believe that. So we have two space types. We have wood and carpet. Now, a part of doing the dissertation project was writing about potential add-ons. The main thing I just focused on here was the artificial intelligence, but I did also go into, in the report, all the different extensions which could be made. So ideally we could have different floor types affect how the robot achieves goals, how quickly it moves, things like that. But these aren't really used. Both of these are basically just the normal space type, whereas we can have things like walls which block the movement of the robot. So if we imagine this is the wall, I drew this. I think it doesn't look too bad for something I've drawn. You've got bricks here. We imagine like a top-down view, so we've got the wooden floorboards here, and then two layers of bricks with insulation in between. There we go. So you can see which direction the walls are going by looking at this insulation there. I think that was an okay way of doing it. There's probably much better ways of drawing that, but yeah, as I was saying, the artificial intelligence is the most important part. Coming to the artificial intelligence, we have these two buttons here. So we've got on and off switch, artificial intelligence efficient planner and robust planner. So there are lots of different ways of implementing planners. You have to give a sort of a structure to the way it solves. It organizes the routes to construct its plan. So you make the algorithm itself, but then you can also prioritize certain actions, certain things, and the efficient planner prioritizes them in a way which almost always, I haven't found a situation where it's not the most efficient route first. It always organizes it so that it moves the least possible number of spaces. The robust planner, however, it just does it in so it's not a ridiculous order, but it can move over the same space multiple times, forget that it's been to a place and then attempt to pick something up twice, so that sort of thing. But the problem with the efficient planner is there are a few, I can't actually remember them off the top of my head, there are a few niche situations where the efficient planner cannot work, and I pinned them down and wrote them down in my report. I think it was where an action satisfies a goal in addition to the goal. Like if for example the robot was here and it moved to here to satisfy a goal such as picking something up, if in that movement it both picks something up and satisfies a goal. So for example, if there's a mop here and then a spillage here, and your robot wants to pick up a book, in the movement like this, picks up the mop and cleans up the spillage, and then you pick up the book. In that situation, if a route was supposed to be ordered after the cleaning up of the spillage, it can't be done anymore because the spillage isn't there anymore. That's probably really hard to understand, but that's the sort of situation where it can occur. So yes, that's an explanation of the two different planners we've got there. The robust planner is simply implemented by a if statement, which cuts out a lot of the checks, which ensure that it's efficient. So that's not as hard to implement, this little thing. Robot control. It cannot be accessed yet. When the planner is running, and the robot's running, the planner acts straight away, and then the robot runs. Once the robot is running and it's in the area here, and there's a robot controller which allows you to move it manually. That's just sort of a testing sort of thing that I've left in there, which is nice to play around with. We've got a presets menu. So the presets menu generates us some environments. So I've put 2 in here. So I've got 2. This is like this little maze sort of thing. So we've got a little spinny. We've got a little block there. Some things sticking out. In this one we have little 3 rooms with doors. What else we got? Layout. So we've got the layout here. Layout menu. These are all different walls. You can have doors. Doors don't really do anything. They're just sort of decoration, and robots can move through that easily enough. These are the corner walls. Nothing more to it than that, making everything look nice. Features. This is the more important part. So the features are a collection of goals and solutions to those goals. So we've got a water spillage here. It's just little puddles of water, and we can place a mop into the world as well. So the robot would go and get the mop, and then go and clean up the spillage in this case. So I can try that out. I think the efficient and the robust planner should work exactly the same in this case, but we'll leave it in like that. And we've got the inspector. So once we've clicked inspector, we can click on things to learn about them. So mop, so that's some spillage there, so spillage, wall, carpet, not much else to it there. Starting location, this is the down button. You can pick the starting location, that's where that crosses, that's where the robot spawns. We can press reset, and that resets the environment. And finally start, so this should generate the robot. Here's the robot. I just downloaded the robot from an open source website, I think. A little robot sprite. And then I did some stuff in an image manipulator. GIMP, I think I used GIMP. And I just moved the arms left and right, and you might be able to make out that the arms are moving left and right as it's moving, just a bit of animation there. And then the robot moves and it cleans up the spillage. So it's got the mop and then moves up the spillage. So it does that by finding all the routes between key locations. So it found this route, then it found this route, then this route, then the route from spillage to mop, mop to spillage, mop to robot, robot to mop, and then it looks at what it wants to achieve. So it knows it wants to achieve this spillage cleaned up, and it finds it goes, what do I need? I need to be at this location, and I need a mop. So it will either find a route from the mop because it needs a mop to the spillage, or a movement from the robot to the spillage because it needs the robot to be at the mop, at the spillage, sorry. And then after picking that first movement, it will then backtrack further and then try and arrange everything so that it's achieved every single one of its goals. So in the case of it going from robots to spillage straight away, it's going to quickly realise that that's not the way to go about it, and then it's going to reorder and remove some of the routes it's already ordered so that it can get to the right thing. So the way it works is you'll have an object which are steps, which are considered steps, which represent different movements, and then it will order them, create links between them. If it doesn't think some are correct anymore, then it will remove the links, so that the movement doesn't occur in that way. It's quite hard to explain. There's a lot to it. I could give you a quick look at the code. I might do that after I've demonstrated all this stuff. So there's the reset button that resets everything to the beginning, and let's generate a different preset this time. And the robot can also solve multiple goals at the same time. So let's put a hanger and a wardrobe in there. So the robot, to solve this goal, it needs to put the hanger in the wardrobe. So it collects the hanger, walks over. There we go. Always a bit of a worry when I do things like this, because I'm afraid it's going to bug, and then and then I'll have to fix things. Because I haven't worked on this for quite a few months, well, since Easter, so. And it's summer now. Okay, so that worked perfectly fine. I think I did fix most of the bugs in this, so that's good. It can also, so we know it can order routes so that it can fulfill one goal, which is to put away a hanger, but it can also satisfy multiple goals. So, for example, if we have a mop and a spillage in there, it should be able to order them. We have the efficient planner on there. It should be able to order them so that it completes all of these goals. So it's collecting the things it needs to carry out first, and then it's walking around. So that wasn't very efficient, was it? That wasn't particularly efficient. Now there's lots of different efficiency checks. It's a lot more complicated than it may sound, ensuring that it always makes the best movements. Because you can see here that it's successfully identified all the goals, and it's carried them out nicely. After a few months of me working on this, I was nowhere near at this stage, so that would have been absolutely mind-blowing a few months into this project. Anyway, yes, so there's so many different checks and things you can do to ensure that it always makes the best sort of routes. So it's often not just as simple as finding the shortest distance between different key points, because obviously there could be walls in the way. There's all sorts of problems. Sometimes the same item multiple items can be satisfied by the same multiple goals can be satisfied by the same thing. So if there were like 3 hangers, you could have the same wardrobe to put it away in, so it all becomes quite complex in that way. So the efficiency checks that I've got in here, there aren't actually that many. They didn't go into a huge amount of detail in the efficiency. I only put like 2 or 3 in just to show that how you'd do it, and then I put that in the report. One of them being, I think, if what was the efficiency one? I can go back to the one. Yeah, the thing that was causing problems. Yes, the thing that was causing problems. So if it if it makes a movement and it encounters goals along the way which it wasn't expecting to, then the efficient planner makes a note of that and satisfies the goals. But then it makes further route finding very difficult. It was probably quite simple to fix that. I just didn't actually get into it. There's just so many. This is such a big project, and there were lots of different things to be doing, so I never actually got around to fixing that problem. But yeah, that's the way an efficient planner, efficient planner does work and cuts down the amount of movements you make. So if it didn't make a note of those additional goals that it satisfies along a movement, then it would have to go back. So if it, like I was saying before, let's stop this. If I was saying before, if you move from the left to the right, and then there was a goal midway through, then if the efficient planner didn't make a note of satisfying the goal, then it would go here all the way back and then back again, which isn't great. And you might say, well, why doesn't it satisfy the closest goal first and then move on to the furthest away ones? Well, it's not as simple as that. It's not. You can't use greedy rules like that. Doesn't work. I have tried greedy rules like that. They don't work because the way the goals are structured. Some are you move an item to another item, and others are you collect an item then take it somewhere, which is very, very similar. And I have to explain this to you. So there we go. So for example, it's this. I'm gonna have to think this out. I'm sorry. So there's some goals which are you collect an item and then take them to a location and put them away, where some goals are you collect an item and then use it to satisfy many goals. So there's sort of opposites, if you can see that. It did take away like a couple minutes for me to get my mind around it when I was figuring this out. But yes, it's for things like that is the reason you can't really use a lot of greedy rules, which makes this really difficult. But yes, I'll show you a couple more things. So if we start the robot with nothing in there, I'll go into the robot controller, and this is just robot controller here. The idea of this was just a bug finding thing. So testing that all of the features interacted with the robot properly. So the features are just objects which appear above the spaces, and then the robot runs into them and picks them up by interacting with them and touching them. So there's probably more clean ways of doing this, but that's the way I chose. It felt nice because it actually had objects that I could see and play with. There's probably a better way of doing it, as in I was gonna say storing the information at the space, but I do store that information at the space because that was important for all sorts of things. But yes, there was probably a better way of doing it than the robot actually colliding and moving into the object and touching it. But yes, there we go. So this was really helpful for watching the robot. I've tapped these buttons, let it go exactly where I wanted it to, when I wanted it to, and had it interact with the spaces, and made sure it does exactly what I wanted when it touched them. And what else we got? Let's try one more thing. Just one more thing before I give it a rest and I'll have a look at the code a little bit, I guess. Okay, so we've got a basket. Basket's one of the last things to show you. And we can put clothes away in the basket. We could also put clothes away in the wardrobe. Now, a efficiency thing here is you could have it so that it picks the closest out of all the wardrobes and baskets to the clothes that you pick up. That's a thing you could do. It's not quite as simple as that though, because obviously the way the plans are ordered, you could pick up this one first, and then you could pick, wait a minute, this is a better way of describing it. You could pick up this one first, then this one first, then this one, and then it would pick the closest basket or wardrobe to this one, or it could pick the closest wardrobe or basket to this one, and you've just got to hope that it ends on the right one, and then it moves to the closest one to that shirt, which makes sense. I don't know if that makes sense. So yes, so the closest basket or wardrobe to this one is this basket. The closest wardrobe or basket to this shirt is this wardrobe. But if you mismatch them, you might end up having this one, a robot here, go to the wardrobe over here, just the way the plans are ordered. So you'd have to put more thought into it, and maybe post-process the plans so that you match the right wardrobe or basket up to the clothes that you land on last. Because the most efficient way is usually to collect all of the clothes first and then put them in this basket all in one go. Yes, yes, I'll fire away. I haven't tested this sort of thing, I think. Ooh, did that work? Ooh, what was he doing? I'll just look at the console. Incomplete. Oh, well, there's a small number of bugs remaining in the project, but it was a tough thing. So let's put the basket in there. 1 second. And there's a lot to the project. There's a lot more to it than it appears as well. Sometimes there's tiny things and I can't really imagine what the problem could be. And it takes a little while of looking at the code and experimenting with some bug fixing and troubleshooting for it to be fixed. This project involved quite a few lovely days of bug fixing. Very enjoyable stuff. So there we go. So there's a nice little animation as well. You can see the the clothes have been put into the basket. Very simple image editing there. But yes, as you can basically see the gist of what's going on here. It identifies all of the goals it needs to achieve, and then finds out how it satisfies each of the goals backwards from the ultimate aim there. So I'll just have a quick look at the code to show you, because that's the most interesting part. It's hard to gain most of what's going on from just just this. So I'll quickly cut to the code for a very short time, because can also all often be very hard to take in if you haven't been familiar with the project. I'll just give you an overview. So basically you'll see these comments everywhere. Step 1 termination, etc. I basically learnt this algorithm from a research paper from Washington University. So I made sure I laid out the steps and I was meeting everything in order, because it was on the paper, it was ordered in, it was 6 steps I think, and it was a recursive algorithm, except this one is iterative, but you can achieve everything iteratively that you can do recursively, and I think iteratively definitely fit how I was arranging this, going about this better. I think recursion would have been a bit of a nightmare. So yeah, we create a UCPop planner. That's UCPop is the planner I'm using. UCPop planner object. You give it a bunch of goals, all the different actions which are possible, and it will prepare the plan, and then it will make a collection of the goals which are left to be satisfied, and then it will repeatedly select a new action, create a step for the plan and add it in there, link everything up so that the movement works correctly, and then it will remove the goal that it's satisfied, and then reintroduce any goals which have been created by adding in this new step. For example, if we want to clear up a spillage, we'll add a movement from the mop to the spillage, and then that in turn adds a requirement to be at the mop. So then you need to repeat the algorithm again to satisfy the requirement to be at the mop, and so on. And there's all sorts of funkiness, so it's not too bad. I spent a lot of time on this. It's not too inefficient. There are some dirty things like this, where I have a flag which skips the loop. I'm pretty sure I could have restructured that a bit better, but the reason I have that is there are certain situations where it doesn't need to find a new action. So here we go. So you can see we've got new links that we have to construct. We have to pick. We have to add new orderings. You have to identify any additional links which need to be added in to the plan. So when you add in a new step, there can be additional links, there's more than just one link required to meet it, because that's because sometimes when you add a movement, it satisfies more goals than the one you are expecting to satisfy. So that's a check to identify all of that sort of stuff. And there we go. So there's certain situations where we don't want to add new steps or actions, and those are when we are just satisfying like sort of goals which are grouped up. And the way you satisfy goals which are grouped up is by simply removing them and adding in new goals, multiple goals which sort of divide and conquer what you're looking for. So if we're looking at be at a location and have a mop, then we're going to split that down to be at a location goal and a have mop goal. So that's sort of a divide and conquer approach, and that's the way I've done that, and I feel that was quite a nice solution. But obviously the structuring isn't fantastic because I've had to add in that little check. But yeah, I'm sure I could redo that and it would be really nice. It would be a lot nicer, but that's a good way of doing it. And yeah, so we've got termination conditions that has to go at the end because recursion sort of stops early, but iteration doesn't. And lots of different debugging, so much debugging, because as you can see here, print plan, I've made lots of functions just to give debugging information, because it was so hard to identify what was going on without really detailed debugging printouts in the console. So yeah, not much more I can really show you there. I'd have to give you a big lesson in loads of different things to explain much more. Otherwise, it's going to be a lot really in depth. I've obviously implemented this all myself using the Washington documents. I also implemented my own searching algorithm. It's an A-star searching algorithm to find the distance between locations and find good routes and everything. So yes, hope you liked that. I'll see you later.